Hi, my name is Fraser and welcome to Graphic Card Repairs. So today we have this Gigabyte Eagle RTX 3090 and the user says that it doesn't boot with the graphic card installed. So let's check some resistance and check if we have any shorts. Let's check the 12 volts PCIe and we don't have any short. Let's check the 3.3 volt. We don't have any shorts. 8 pin. We don't have any shorts. The second 8 pin. We don't have any shorts either. Okay, so let's put this card on the bench and let's put this card from on the internal display and let's check it. So the card is on the bench and it's on the internal display. Let's boot it up. Okay, the display that you see is through the internal display and not the graphic card display. So I'm going to run mods first. Since the card is connected as secondary, so I'm going to run the command mods init. And we can see that channel D1 is the one that's showing faulty. Let's run NVMT. Okay, let's open the report, the log file. And scanning through the report, we see D1. Okay, there's nothing here. Let's scroll down. Okay, I can see an error here. It just shows me one warning. Let's check here. Sometimes NVMT can really be finicky. It shows errors, sometimes it doesn't, sometimes it shows something very weird. It's just that you have to combine all the three and then judge whether what's the thing that it's showing faulty. Okay, so D1 is what's showing faulty. Let's shut this thing off and let's put this card on our work area. Let's stick it there and let's open this card up. So if you're wondering why the user said that it's not booting with the card even though it has memory errors, is because GDDR6X, if it has memory errors, it doesn't boot. It gets stuck on error code B2. If you have post postcode display, it will show you error code B2, and B2 means there's a fault with the VGA. Whereas GDDR6 will boot into Windows and show error code 43, or it may show a black screen after showing the BIOS screen and things like that. So it can change. GDDR6X is a little bit different when it comes to booting, so you just have to be mindful of that. Okay, so the card has been dismantled. Let's check A1, A0, B1, B0, C1, C0, D1. Okay. So D1 is the faulty one, and that's the one that's that we need to remove it. So in NVMT report and mods and things like that, it doesn't show us now. 3090 has memories at the front as well as at the back. There is no way to identify whether it's the one at the back or the front, but we may have to remove both and reball it. So I don't think the memory itself is faulty. Maybe there might be some broken connections and things like that. So it's just uh, I may have to open it and probably reball and put it back again. But we'll take a look after we take the memories out. So I'll just take this IO plate out. Sorry. Looks like the thermal pad was overlapping. Okay, let's take a look under the microscope. Okay, let's get rid of this thermal pad that's stuck between the memories. So because because we don't want these pieces of thermal pads, moving into the other memory, so it may even short the the memories on the other side, which we want to avoid. Okay, that looks much better. So what I'm going to do is I'm going to first remove the one on the top, reball it, put it back again, and then remove the one at the back and reball that one. Okay, so let's go ahead and start to remove these memories. Okay, there you go. We can see a shot on one of the data lines. There you go, that's a shot. So I wonder if the shot is coming from the other side of the board, or is it coming from the GPU core? I assume it's from the GPU core, and it's not from the other side. But this is definitely a shot on the data line. So data line is shorted to ground, which is not a good sign. The rest of the pads are fine. I don't see any shots there. Okay. All the other data pads are good. They show me a good reading, except for one which is shorted to ground. So it could be that this was the reason why we did not, or we have that error. So that's why I measure the data pads. So just to make sure that there's no short on the data lines. And we found our fault. This was the reason. So you know what that means, right? That means we have to reball the GPU core. So let me just check if anything has shifted, or if the memory has shifted while I was taking the other one out at the back. The front looks fine. I don't see anything wrong. Okay, so it's time to reball the GPU core. Let's prepare this card, and let's put it on my machine. Before that, let's get rid of these pads. The core is going to be reballed now. Let's remove these pads. So my question to you is, how important is it to measure the data lines whenever there's a memory fault? For example, if you need to replace a memory, you identify that there's a fault with the memory. When replacing the memory, how important is it to test the data lines? So put in your comments in the comment section. I want to know your view as well. So yeah, go ahead and fill in the comments. Okay, so this card is now ready. Let's put this on the rework station, and let's remove the GPU core. Okay, so the core has been reballed. So the first thing you do after you reball the core is to measure the resistance, just to make sure that there's no short, because after you reball there's a high chance that there might be shorts. So let's take the resistance. We'll start from the 12 volts again, and we don't have a short. Let's take a look at the other 8 pin, and we don't have a short. Let's take a look at the 5 volt. We don't have a short. 1.8 volt. Okay, we don't have a short. Let's check PEX, and we don't have a short. So PEX looks fine. It's slightly low, but it's okay. Let's check memory, and that's good enough. Okay, so let's check if our short on that data line, if it's gone. Okay, let's test it now. Oh, sorry. Let me move the multimeter so you can see the reading as well. So the short is gone, but I want to show it to you. There you go. So you can see that the short is gone, that we no longer have the short on the data line, which is a good sign. Okay, so I'll install this memory back, and we'll proceed from there. So the core has been reballed, which is good, and we don't have any shorts. Let's proceed to install this memory. Okay, so the memory has been installed, and we've put this card on this bench. I'm booting the directly from the card and not from the internal display. I'm just going to check if we get a picture. We do. So I'm not going to run MATS now. I'm going to install the cooler and then proceed to run MATS and other stress tests. So let's install the cooler. Let's clean this thing up a bit, and then I may have to replace the thermal pads as well. So let's do that, and then let's stress test this card. Okay, so the card has been assembled. I have replaced the thermal pads at the front of the card, and the back was fine, so I haven't replaced the memory or the thermal pads at the back. So let's first run MATS, and let's check if it passes. Now you might be wondering, why I did not run MATS first. So over time you get to understand, with experience, if the card is really going to pass or no. So it's just that I already know that it's going to work. So that's why I just checked if it's going to run or if it's giving me an image. If it gives me an image, I know that MATS is going to pass. But right now I'm just, for the sake of this video, I'm going to run MATS again and show it to you. I'll just wait for the results. There you go, MATS has passed. So I'm going to shut this down and boot into Windows now. Okay, let's boot into Windows. Okay, it's taken quite a long time. Let's boot into Windows now. So once it boots into Windows, I'm going to wait for the drivers to load, and then I'm going to run, a couple of different stress tests just to make sure that the card is really stable. So drivers are loading right now. There you go. Drivers have been installed. Let's check that, verify it. Drivers are working properly. That's good. I will open GPU Z and run FurMark first. Okay, everything looks good to me here. The temperatures are normal. That's because the card is just idle. Let's run the stress test. So I'm running FurMark now, and the power consumption is at 100%, which is good. So the clocks are not boosting as high because it's always in FurMark you will never find the clocks running super high. It's just bare minimum. It's always with FurMark that it will always boost at the base clock, not at the boost clock. Running Heavens now. So in Heavens, you'll always see that the clocks boost really high above the the boost clock. Okay, let's open 3D Mark, and I'm going to run Speedway. So this is the last stress test that I'm going to run just to make sure that everything is looking good. So we don't have any artifacts. Everything is nice so far. So if it survives Speedway, I know this card is going to last a long time. So this is the last test that I'm going to run. So what do you think about this repair? There's a lot of information that is been shown in time lapse, do let me know in the comment section if that's the way you would want to see it, or you would want to see it more in detail, in the normal speed, not in time lapse. Do put in your comments in the comment section, and do let me know about it. So I hope you like this presentation of this video. If you would want me to change anything, do let me know. I also make sure that I read every comment, and I also respond to every comment. So I think that's about it for this particular video. If you like the video, please hit the like button. Don't forget to subscribe for more content like this. Thank you for watching. You have a good day. Bye for now. Cheers.